Hi, I'm Harut Markarian, and this is Mobility and Inclusion, the show where we share the powerful stories of people with disabilities and daring entrepreneurs making waves in our world. From technological innovations to best practices in business, we'll learn what it really means to live in an inclusive and universally designed environment. Welcome to a new episode of Mobility and Inclusion. I am Harut Markarian, and my guest today is Andrew Ekelem. That's Dr. Andrew Ekelem, who fell into neuroengineering after a snowboarding accident resulted in a spinal cord injury in his early 20s. His own journey through neurorehabilitation sparked a passion for developing rehab technology that empowers mobility. After obtaining a Bachelor of Science in Bioengineering at UC Berkeley, he completed his doctorate in mechanical engineering at the Center for Rehabilitation Engineering and Assistive Technology at Vanderbilt University. His doctoral research focused on combining human power with robotics using functional electrical stimulation, muscle activation in other forms, during exoskeleton-assisted walking for persons with paralysis. Now, Dr. Ekelem is Chief Product Officer at Evolution Devices, where the mission is to provide the paralyzed community with financially accessible rehabilitation technology. Dr. Ekelem, Andrew, welcome to the show.
Thank you. Thank you so much for having me.
It's a pleasure for us to have you and to host you. Looks like we got a lot of things in common, man. We're both engineers. We're both in the assistive technology world. So from your bio, I got that you were injured during the snowboarding accident. So take me through that. How, what were you doing? How did you get injured, and how you fell into neuroengineering?
Yeah, I was having too much fun. I was snowboarding, so I loved all kinds of sports. Played everything from soccer to basketball to golf. You name it, I've probably tried it out. So I was always interested in kind of just exploring and learning, and snowboarding fit the bill pretty well. But yeah, I was just getting into it. So I was going up almost every weekend and trying to learn new tricks. And I went off of this jump when I was 20 years old and doing things I shouldn't have been doing. Should have been going a little bit slower, went a little bit too high, came down a little bit too hard. And I almost immediately knew something was wrong when I couldn't get up. I couldn't feel my legs and had to, pretty self-explanatory, but I broke one of the vertebrae in my back and injured the spinal cord thereafter. So getting helicoptered out, barely conscious, and waking up with my family who flew hundreds of miles to be by my side the next day. And it was a very traumatic experience, just kind of having that much of a physical kind of injury, and then learning all the diagnoses that come along with that, and the prognosis that it's not that common that people recover from injuries like that. When the brain gets injured, it recovers slowly, and the spinal cord has a limited capacity for neuroplasticity. But yeah, it was definitely a learning experience. And being 20, I was in college. I took that experience, and it's kind of motivated me to learn as much as possible about neurorehabilitation, all these technologies that kind of can help influence that. So I've explored things like stem cell research at first, and then got into robotics because I think that suited me a little bit better, and electronics and programming. And here at Evolution Devices, what really excites me about what we're doing is the machine learning aspect. So building new controllers using neural networks and stuff, so that robotics could be a little bit more intelligent than heuristic controllers that we used to designing.
It feels like we both have a similar path. I was very active in sports. I played professional basketball. I did some skiing and stuff like that. So when you're talking, I'm like, this guy is like a different person in my body, right? It's like, you know what I mean?
So yeah, kindred spirits, nice.
Yeah. and then going to engineering, and then robotics, and then now really in the assistive technology world, it's kind of like we're walking the same steps pretty much. So I always had a fascination for neuroscience, right? I wanted to know how the brain really activates all the muscles, because I wanted to apply that for um, prosthesis, right? Prosthesis that connects to your nervous system, which is, for me, is a very cool concept, right? So tell me, like, why did you decide to go into neurobiology?
Well, after the spinal cord injury, yeah, I think I had to learn more. So I took what was my favorite course in undergraduate was neuroscience, and it's unbelievable the amount of creativity that it takes to just to unravel the brain, all the secrets of what makes us tick, what makes us think, what makes us see. It's absolutely phenomenal. The biology, the design of the brain. So it is just fascinating. And let's see, there's a lot of challenges that came along with trying to complete school, and my body just went through this metamorphosis from snowboarding to being a paraplegic, using a wheelchair, having to stretch, having spasticity, and yeah, just adapting. So I definitely wanted to learn more and focus on recovery, but also still finish college. So it was kind of hitting two birds with one stone, kind of.
Oh, that's awesome. Exactly as you said it, like two birds in one stone, and it's all of interest to you. So I'm pretty sure you were loving it as you were doing it, right?
Yeah.
It makes a whole lot of difference, and a lot of people go through school just to get a degree, right? But that wasn't the case for you, because you had passion for it, and then you probably had a future intention into what you were going to do with all this stuff.
Absolutely. Yeah.
Yeah.
Yeah, it's an interesting path. I just took it one day at a time, one struggle at a time. So the college I went to is on Berkeley's campus. It's just one big hill. So started my engineering days, just designing new wheelchairs and getting into mechanical design a bit. But then, also trying to neuroscience then steered me away from that a bit, and even got really interested in stem cells. And there's so many facets that came along with recovery that is a good educational experience, even though it's an unfortunate traumatic event. You gotta take what you can from the experience. So
Exactly. You have to look for the good in any situation, right?
Yeah. It's been an interesting journey, that's for sure.
Absolutely, and I can only imagine. So so what you did your PhD doctoral program in Vanderbilt, right?
Yes.
Yeah, you can talk to me about your thesis project.
Oh, sure. So yeah, again, this was a great program because I guess towards the end of undergraduate, I started doing undergraduate research in exoskeletons with Dr. Kazaruni at Cal. He's invented actually Sudex. I don't know if we should be talking about companies, but he's invented a lot of different exoskeletons. So I had the pleasure of working with him, and just randomly one day in the lab, another researcher introduced me to functional electrical stimulation.
Mm-hmm.
So I was like, wow, we could activate the muscles just by putting electrodes over them, and then running some electrical current. Goes through the skin. It doesn't, for some people, a little bit more sensitive to it, it might feel some, but generally you don't even feel it, and it could activate the muscles underneath it. Yeah. So I was really intrigued to combine, that human power with motors. And yeah, so this is on the early onset of exoskeletons becoming feasible, just due to manufacturing constraints. The size of the weight of the motors had become small enough, and electronics become dense enough as well, that it became feasible for people to use exoskeletons for rehabilitation. So it was really exciting to see the early ones being built. and there aren't that many. They're just basically leaving university settings. So that's why I was attracted to go to Vanderbilt and work with Dr. Michael Goldfarb, who invented the Indigo system. And we were on the same page as far as integrating electrical stimulation with the exoskeleton. So that's where I went in there. I kind of learned how this exoskeleton is controlled, and then how to build the functional electrical stimulation electronics, program it, wire the two systems together, and even managed to do some pilot testing on myself. I was the first guinea pig, and then we would recruit other spinal cord injured subjects to try out the new technology.
And that is so cool. Like as you're talking, I'm getting goosebumps right now, because I'm like, yeah, I wanted to try that exoskeleton, you know?
Yeah. Yeah,
And I
no,
mean, it's pretty cool. I mean, I understand because I've been in the same setting. Obviously, you understand because you lived it. But people who are not doing these research, or who are not involved with testings, they don't really understand the joy when you actually work on something and then get to try it and test it. It's really cool, right?
that's the best part. And usually the first few times you try it, it may or may not work. So yeah, you try it on yourself in small steps. But by the time that you get it to work, and then you show other people, and then you see the excitement in their eyes, it's not work anymore. This is just pure rewarding. It's amazing.
Yeah, that's something I tell. So I worked with BCI, brain computer interface, back in college, and we were propelling a wheelchair with our thoughts, right? The same concept that you explained. You know, put electrodes on the brain or on the skull, and then pick up that electrical signal and transfer it to the motors. And we were testing it, and as we were testing it, we weren't as effective because, you know, I don't think about propelling a wheelchair in my everyday life. But for a wheelchair user, he has a different way of thinking about how to move around, right? So when I started testing this wheelchair, it was like I was barely able to move it forward and backwards. But then the real guy came, the real wheelchair user came, and man, he was driving that wheelchair as if I was driving the car. You know, the same thing.
Oh wow.
And to your point, you see the excitement in his eyes, right? When he's able to do that, and that feeling that he gets, and then it just, that is worth everything. You know, it's like now you forget all the all-nighters that you pulled to finish the project, right? You forget about all of that. It's just like that fulfilling feeling that comes with seeing someone happy with what you delivered, right? It's like it's a value delivered. So it's really, really important and really nice. Now, so how did you started with evolution devices?
Yeah, sure. So as my tenure at Vanderbilt was coming to an end, just finished the dissertation process, and yeah, the whole motivation for me getting into grad school was really about the technology. I was happy to see that exoskeletons, you know, were coming to the market, but there's limitations for patients. You know, there's limitations on reimbursement and access to this technology. So I was like, okay, like what can we do? You know, like as far as getting rehab technology to patients, I was like, maybe we got to start smaller, and just take the electrical stimulation aspect, which the electronics are, you know, fairly affordable, and then so yeah, so the idea was let's see what the journey would be like to come into the FES space, the functional electrical stimulation space, with a product.
Yeah.
And really like learn why are other FES devices the price that they are, what goes into making them, what is the process like for a product. So that's why I steered away from academia and really decided to go into industry and bring a product to people. Again, like look for that light in the end user's eyes, that it's really helping their lives. So let's see, at the time it was 2018, in the fall. I just finished grad school. I was applying to numerous grants, and heard of Evolution Devices through one of those grants, actually, because they they were awarded one of the finalist awards for the Toyota Mobility Foundation. And yeah, so I contacted them, and we had very similar missions as far as bringing technology to people that normally are left out. Bringing the good technology too, not like the really old technology, nothing like.
I actually want to commend you on that, because most of the time these people are left with, the community of people with disabilities are left with kind of old technology like walkers and crutches and I don't know what, And I was talking to this one person who's a very dear friend of mine, and she had a spinal cord injury. And she says, I no longer want to deal with crutches and wheelchairs and walkers. I want something that comes from the Jetsons. You remember that Jetsons cartoon?
Oh yeah.
I want cutting edge technology, no more of that walker stuff. It's like, if you're going to create something like that, then I'll be working with you. If not, don't bother. So it was very eye-opening, because as you mentioned, they're always left behind. And that's why, when I started my company, I said, Robotics is the name of the company, and underneath I'll go like where nobody gets left behind, because that's a big part of who they are. They feel like they were left out all these years, and I'm actually glad that you brought that up. And so I was going to ask you, so if you're going to work on a project, how do you ensure that this is something that the end user, like you mentioned, the end user is looking for? How do you determine that?
Through a process called customer discovery. We just ask questions, we interview. We were fortunate that the Toyota Mobility Foundation, they helped us with a lot of publicity. So we were able to really engage with the community. Like for instance, being hosted on the local news, and we announced our info at Evolution Devices email, and we were able to get a lot of great, just input from the community, like, oh, hey, this seems like something that might work for me. This is before the pandemic, but we were able to invite people to come to our office, try out our prototypes, and see what the effects were, and just learn from that experience what would be easy for them to use. And it was a very iterative process of discovering the customer, their needs, and then trying
because
to.
Another thing about this community is they don't like to be told. From an outside perspective, they don't like someone coming in from an outside perspective and saying that this is what you need to solve your problem, right? They want that partnership and collaboration, which is what you're talking about, which is great to hear, actually. And I'm going through a lot of that as well, like the iterative process, right?
Yeah.
Now,
user-centered design.
Yeah, exactly. Now you're crowdfunding for the EvoWalk Smart stimulation system, right?
Yep.
So go ahead. This is your chance to ask for money, man.
Yeah. Right here, I have the EvoWalk stimulation system. So this is a current prototype that we have. It's a wearable that straps around the leg, and it connects with sticky electrodes. So these are off-the-shelf electrodes, again, to just bring down the cost for the time being. But well, hopefully for an enduring amount of time, we'll bring down the cost. But we really designed something that's as simple as possible. Just a elastic strap, kind of a nice magnetic clasp, so that people with limited dexterity could manage it. But yeah, really most of the effort has gone into the AI, intelligence that turns the stimulation on and off at just the right times, while somebody with paralysis who has difficulty walking needs that stimulation, needs that extra support. And it sends a bunch of information to the user. And another interesting thing that we think is fairly innovative is the aspect of tele-rehab. So introducing patients to this just by sending them a device and having a physical therapy, walk them through an 8-week program, just one hour a week, on how to use the device. If they have any questions, any concerns, and really get a feel for the device before they decide whether it's something that they'll find useful for the long term.
Yeah, that's really interesting. Think about how much you can expand your reach by doing what you just said, right? By like doing that telecommunication, if you will, between the provider and the patient and the physical therapist. So you can really talk to a person at the other side of the world, and then offer them their product and the services of a physical therapist, which is great. And this kind of thinking was not even present maybe 5 years ago, right? Or barely was getting there.
Yeah, that's funny. I mean, I guess it's not funny. It was really the pandemic, and like for example, we're on Zoom now. I didn't do that much before 2020, and we couldn't have potential users coming to the office anymore. So we were forced out of hardship, into this tele-rehab, and we realized it's feasible. It's these patients are learning within an hour, usually the first hour, how to use the app, use the device, place electrodes in the right places. Things that we thought maybe that would be unfeasible, we're finding is actually feasible.
Absolutely, man. That's great. So how can people get in touch with you or anybody in the company? And how can, what are you looking for from the community, from investors? Go ahead.
Sure. Yeah, we're taking on pilots with an upper motor neuron damage through stroke, multiple sclerosis, spinal cord injury, traumatic brain injury. There's numerous causes of foot drop. So that's our first kind of users of the EvoWalk. And clinicians, we welcome clinicians to work closely with us as well. We'll send some samples so that they could try it with their patients. There's a lot of information on our website. So if you go to evolutiondevices.com, then you could see more information on how it works, and sign up for our newsletters. Contact us through email at info@evolutiondevices.com. Check us out on Instagram, on LinkedIn. Really, we're very interested to interact with the community. We're doing a crowd equity fundraise so that we're funded by the community, so that we have full control over the pricing of the product, and the way that we want to introduce it to the community, and that benefits the community the most.
And you're based off of Los Angeles, correct?
I live in Los Angeles. Again, with COVID, we've kind of dispersed a bit, but our headquarters is in Berkeley, California.
Okay, got it. Okay. So there you have it. If you go to evolutiondevices.com, you can find a lot of information. You can also reach out to them through there by, I think you said info@evolutiondevices.com, right?
Yeah, that's right.
Awesome, man. And maybe you never know, maybe one day we will work together.
That'd be great. Yeah, I'm very interested in robotics too. It's great work.
Yeah. So I mean, we're trying to partnering up, solving problems by partnering up with the community of people with disabilities. That's what we're doing. That's ultimately our goal. And thankfully we have a good community around us. And that's all I can ask for, to propel the mission and the purpose of the company to the next level. All right, man. Thank you so much for your time, Andrew. This was great. I mean, I can talk to you forever, but our guests are not going to understand a lot of what we talk about. Probably a lot of the technical stuff. But this has been great. I thank you, and please again go to evolutiondevices.com, and if you need access or help with foot drop issues, you can contact info@evolutiondevices.com and reach out to them. Thank you, everyone. Thank you, Andrew. I will see you next time with a different guest. Bye.
All right.